Good evening everyone and welcome to the Q&A session 43 from the playlist of NEET Physics part 1. Now the chapter is the work, power and energy, and I have taken one question for this session which is based on the law of conservation of energy, and this question was asked in the CBSE All India Pre-Medical Test in the year 2004. So the question here is, a stone tied to a string of length L is rotated in a vertical circle. The stone's speed at the lowest point is u. The change in the velocity of the stone when the string becomes horizontal is. So we have been given here 4 options and we have to find the correct one. Now this question is based on the law of conservation of energy. By using this law of conservation of energy, we will be able to find the solution. So let us try to understand this with the help of a very simple diagram. This is the surface, and let us say there is one stone here. This is let us say this stone is tied to a wall, and let us say this is the string here, and the stone is tied at this point, say O, and this is the stone. The length of the string is L, and this is the surface. So you can say that at the lowest point, we can even take the distance of this stone from this surface when it is at the lowest point. Let us say this is h. So we have to find the change in the velocity of the stone when the string is horizontal. That is when the string reaches this position. So when the string reaches this position, then the height of the stone from this ground will be equal to h plus L. This will be equal to h plus L. Now by using the law of conservation of energy, we will get the equation as, at this lowest point, the speed of the stone is u. So the kinetic energy at the lowest point will be equal to half m u square. The potential energy at the lowest point will be equal to mgh. And this will be equal to the potential energy of the stone when the string is horizontal. That will be equal to mg. Now here the height of the stone from the ground is equal to h plus L plus the kinetic energy of it, where half m v square, where v is the speed of the stone when the string is horizontal. Let us say this is the point B. So when the stone reaches this point V, or you can say when the string is horizontal, then its velocity has been taken as v, and here small m is the mass of the stone. So the kinetic energy, the total energy at the lowest point, that should be equal to the total energy at the point B, which is the point when the string is horizontal. So from here this m will get cancelled out, and finally I will be getting u square upon 2. Here gh is there, so here also is gh, so this gh terms will get cancelled out. So u square upon 2 will be equal to gl plus half v square. So from here u square upon 2 minus gl, this is equal to v square upon 2. So from this equation I can get u square minus 2gl, this is equal to v square. What I have done is I have multiplied this equation on both the sides by 2. So from here the velocity of the stone when the string is horizontal, or when the stone reaches this point B is the point when the string is horizontal, this is equal to u square minus 2gl. So the change in the velocity, When the string is horizontal, this will be equal to, this is the velocity of the stone when the string is horizontal, and when the stone was at the lowest point, the velocity was equal to u. So the change in the velocity will be equal to u minus under root u square minus 2gl. So the correct option here is C. So thank you very much for joining this session. We will be continuing with a different topic from the same chapter of work, power and energy in the next session. So till then, have a nice day. Bye.